Skyscrapers by Chris Oxlade, illustrated by Laszlo Verez. Introduction. Cities all around the world are growing larger and larger. The buildings in these cities are growing taller and taller. These very tall buildings are called skyscrapers. Many reach more than 500 meters into the sky. Every year, more of these buildings are built. When were the first skyscrapers built? In the 1880s, engineers began constructing new, tall buildings in the American cities of Chicago and New York. Even though they had only 10 to 20 stories, they were the tallest buildings at the time, and the word skyscraper was invented for them. Today, only buildings more than about 50 stories high are called skyscrapers. Why are skyscrapers needed? The main reason for building skyscrapers is to make space for working and living in crowded cities. Skyscrapers make good use of space by having many floors, one on top of the other. The Burj Khalifa in Dubai has 163 floors. They include hotel accommodation, as well as apartments, restaurants, and offices. Many tall skyscrapers can be seen in big cities around the world. The history of skyscrapers. Around 150 years ago, American cities began to grow rapidly. New businesses needed lots of space for their offices, and workers needed somewhere to live. Buildings with lots of floors could make lots of space, but the builders had two problems to solve. Firstly, there was no quick and safe way to go up and down inside tall buildings. Secondly, available building materials were not strong enough to build tall buildings with lots of space in them. The lift. Tall buildings need lifts because people can't walk up hundreds and hundreds of stairs to get to their offices or apartments. However, the first lifts were not for people. They moved goods up and down in warehouses. These lifts were too dangerous for people to travel in because the ropes often broke. Then, in 1853, an American called Elisha Otis invented a lift with a safety system. Metal teeth in the system stopped the lift from falling if the rope broke. There were no skyscrapers in towns and cities before the 1880s. Elisha Otis demonstrating his safety lift. Iron frames. The first tall buildings were built with masonry walls. The lower walls had to be extremely thick to hold up the heavy walls on the floors above. Rooms on the lower floors were also very dark because they had to have small windows. People didn't want to live or work in these rooms. At that time, iron could only be made in small amounts. This meant that tools and weapons were made of metal, but buildings were not. In the 19th century, manufacturing methods changed. People were now able to make huge amounts of iron in factories. Engineers could begin to build strong iron frames, like iron skeletons, to hold up tall buildings. Walls could now be much thinner, and windows could be much bigger. The Home Insurance Building in Chicago was the first proper skyscraper. From iron to steel. In the 1880s, engineers began using steel to make the frames for buildings. Steel contains iron, but it is much stronger. Now even taller buildings could be built. The Flatiron Building in New York was one of the first steel-framed skyscrapers. Taller and taller. By the beginning of the 20th century, skyscrapers became taller and taller. 20 stories, then 30, then 40 or more. The Woolworth Building in New York was completed in 1912. It had 60 stories, making it easily the tallest skyscraper in the world at the time. It remained the tallest building until 1930. It is still a famous landmark today. The Woolworth Building, New York. Art Deco skyscrapers. The Chrysler Building, completed in 1930, and the Empire State Building, completed in 1931, are two of New York's most famous skyscrapers. The top floor of the Chrysler Building is 282 meters above the street, and the top floor of the Empire State Building is 381 meters up. Both skyscrapers were built in the Art Deco style, which was popular in the 1920s and 1930s. They are decorated with geometric panels and carvings. The decorations at the top of the Chrysler Building use highly polished metals. Airship Spire. The Empire State Building's spire was designed as a mooring mast for the giant passenger airships of the 1930s. However, it often proved too windy for the airships to stop there. Parts of a skyscraper. The walls of a skyscraper can be made of gleaming glass, beautiful stonework, and shiny metal. Inside, floors are covered with carpets or tiles, but hidden behind the walls and under the floors are many more important parts of the skyscraper. Strong frame. The most important part of a skyscraper is its frame. It holds up the skyscraper's walls and floors and all the furniture and equipment inside. The frame stops the skyscraper from falling down and from swaying too much. Frame details. The columns and beams in a skyscraper frame are made from steel and are connected together with strong nuts and bolts. Many skyscrapers have a reinforced concrete core in the center with a steel frame around it. The skyscraper is made even stronger by these diagonal parts of the frame. Walls and windows. In most small buildings, the walls hold up the floors and roof and keep out the wind and rain. In a skyscraper, the frame holds up the floors. The walls of a skyscraper only have to keep out wind and rain. They can be made of glass or of thin sheets of metal or stone. They hang on the outside of the skyscraper's frame, a bit like curtains. Sometimes they are called curtain walls. Floors. The floors are slabs of reinforced concrete. These slabs rest on the beams of the frame. Lifts. A tall skyscraper full of offices needs many lifts. These move people to and from their offices at the beginning and end of the day. Lifts move up and down in lift shafts. These are usually in the central core of a skyscraper. These workers are installing a glass curtain wall. Rising fast. Some skyscrapers have express lifts to speed people to floors called sky lobbies. Here, the passengers change to slower lifts that stop at each floor. The 104-story One World Trade Center in New York has 73 lifts. 5 of these are express lifts that carry visitors up to the observation deck on the 102nd floor in just 60 seconds. Skyscraper services. Skyscrapers need services just like other buildings. They need a water supply, electricity supply, air conditioning, and communications. The pipes, ducts, and cables for these services run up and down a skyscraper's central core and spread out across each floor. Pumping water. Getting water to the top of a skyscraper is not easy. Water cannot be pumped all the way up in one go. Instead, there is a water tank every 30 or 40 floors, and water is pumped up in stages, from one tank to the next. From the top tank, it flows down to toilets and taps. Air ducts keep the building ventilated. Water pipes run from tank to tank and to kitchens and bathrooms. Electric cables. Under the ground. A skyscraper needs strong foundations beneath it. These support the huge weight of the skyscraper and stop it from sinking into the ground or from toppling over. Reaching the rock. Skyscraper foundations go down through the soil as they need to rest on solid rock. The foundations are made up of long, strong poles called piles. They are made from steel or reinforced concrete. Designing a skyscraper. When a skyscraper needs to be built, a team of architects is contacted. The architects are told what type of building is needed. That might be offices, apartments, a hotel, a shopping centre, or a mixture of all of these. Look and function. The architects begin by sketching ideas for the new skyscraper. They make sketches to show what the skyscraper might look like from the outside and on the inside. When the plans are finished, the architects can begin to work out all the details of how the skyscraper will look. Here is an architect's sketch of a new skyscraper. Loadings. Then the frame must be designed. Engineers work out what the loads on the frame will be. This includes the weight of everything inside the building, the weight of the building itself, and the push of the wind on the sides of the building. Sometimes engineers have to work out how to keep the building strong enough to stay standing during earthquakes. Architects often build a model to show what the new building will look like. Doing calculations. Engineers decide whether to use steel or reinforced concrete to make the frame. Sometimes they need to use both. They decide how strong each piece of the frame needs to be and how all the pieces will fit together. At the same time, they design the building's foundations. Engineers and architects work together to design the other parts of the building. There are thousands of decisions to make, such as what materials to use for the walls, how many lifts will be needed, and where all the water pipes and electricity cables will go. Building models. Architects build a detailed 3D computer model of the new skyscraper they are designing. Everyone can see how the skyscraper will look, both from the inside and the outside. The model also shows how the skyscraper will fit in with other buildings in the streets nearby. Wind tests. Models of new skyscrapers are often put in a wind tunnel so that engineers can see how the building will sway in strong winds. Tunnel to keep airflow even. Model skyscraper made in the same proportions as the new building. Wind flowing through the tunnel and around the model skyscraper. The wind tunnel helps engineers see how the skyscraper and surrounding buildings will be affected by the wind. Building a skyscraper. Once a skyscraper has been designed, work can begin. First, the site where the skyscraper will be built must be cleared of old buildings. Then, the foundations are dug into the ground. Only then can they begin to build the frame. As the frame grows taller, walls and services are added to the floors below. Often, the lower floors of a skyscraper are in use before the top floors are added. Digging down. Pile foundations are put into the ground in two different ways. Some are hammered into the ground by machines called pile drivers. Others are made by drilling a deep hole and filling it with concrete. The concrete sets solid to make the pile. A big skyscraper may need hundreds of piles to support it. A pile being driven into the ground. Building the frame. All the columns and beams of a skyscraper frame are made in a factory and brought to the building site by truck. Tall cranes lift the pieces into place. Construction workers, called fabricators, Connect the parts together with very strong nuts and bolts. Concrete frames are built in position by pouring wet concrete into wooden or steel molds. Floors and walls. A steel deck is laid down to make the floor. The beams of the building's frame support the deck. Then concrete is poured on top. The concrete is pumped up from the ground using powerful pumps. The concrete sets. Together, the steel and concrete make a strong floor. At the same time, sections of wall are lifted into place and fixed to the frame. Rising cranes. Construction cranes are attached to the skyscraper's frame. After a few floors of the frame are complete, the crane's base is moved up. Now the crane can lift materials to the top of the structure. Adding services. As floors and walls are added to the skyscraper, more workers arrive on the building site to install services on the higher floors. More water pipes, electricity cables, and communication cables are put in place. Restrooms are installed too. Expert engineers start to install the skyscraper's lifts. Topping out. When the very top of a skyscraper frame is complete, everybody celebrates with a ceremony called topping out. Higher and higher. Skyscrapers keep getting taller and taller. 100 years ago, the world's tallest skyscraper was the Woolworth Building in New York at 241 meters. Today, the tallest is the Burj Khalifa in Dubai at 828 meters. Can skyscrapers keep getting higher and higher? There are several reasons why this is not possible. Technical troubles. Building super tall skyscrapers is not easy. As skyscrapers get taller, their foundations and frames must be stronger to hold up all the weight above. Strong winds affect very tall buildings too, making them sway. The Jeddah Tower, which is being built in Jeddah, Saudi Arabia, will be the first ever building to be more than 1 kilometre, 1,000 metres high. It will be thinner at the top than the bottom. This stops the top from being too heavy, and so that strong winds don't affect it too much. But engineers think it will be very difficult to build a skyscraper more than 1,500 metres high. An artist's impression of the Jeddah Tower. Too many skyscrapers. If many skyscrapers are built in a city centre, the streets between them can be like dark corridors. In some cities, there is a law against building skyscrapers over a certain height. But skyscrapers are here to stay, and more cities around the world are getting amazing skyscraper skylines. Skyscraper World Tour. Here are some of the tallest and most spectacular modern skyscrapers in the world. Burj Khalifa, Dubai, United Arab Emirates. In 2017, the Burj Khalifa was the world's tallest skyscraper. It contains offices, 900 luxury apartments, and 304 hotel rooms. Its needle-like shape helps to stop it swaying too much in strong winds. Stories, 163. Height of top floor, 535 meters. Overall height, 828 meters. Lifts, 57. Completion date, 2010. Use, offices, apartments, hotel. Shanghai Tower, Shanghai, China. This skyscraper has a beautiful twisting shape and is covered in glass panels. There are 9 sky lobbies in the building where workers and visitors can meet and relax. It also has the world's fastest lifts, which zip upward at 20.5 meters per second. Stories, 128. Height of top floor, 561 meters. Overall height, 632 meters. Lifts, 106. Completion date, 2015. Use, offices, hotels, shops. Taipei 101. Taipei 101 is designed to resemble a traditional Chinese building called a pagoda. Inside, near the top, is a huge steel ball that weighs 660 tons. This swings from side to side, counterbalancing the sway of the skyscraper during very strong winds. Stories, 101. Height of top floor, 438 meters. Overall height, 508 meters. Lifts, 61. Completion date, 2004. Use, offices, shopping mall. Petronas Twin Towers, Kuala Lumpur, Malaysia. This amazing skyscraper has twin towers called Petronas Twin Tower 1 and Petronas Twin Tower 2. They are exactly the same height. A bridge, called a sky bridge, joins the two buildings at the level of the 41st and 42nd floors. Stories, 88. Height of top floor, 375 meters. Overall height, 452 meters. Lifts, 58 in total, 29 in each tower. Completion date, 1998. Use, offices. Glossary. Art Deco, style of architecture that was popular in the 1920s and 1930s. Cable, electrical wire or wires protected by layers of metal and plastic, used for electricity supplies and communications. Concrete, material made by mixing cement, water, sand and gravel, which then sets hard. Ducts, plastic or metal tubes through a building for air, pipes and cables. Engineers, people who design, build or look after buildings and machines. Goods, anything that is stored or moved around. Iron, strong, hard grey metal. Masonry, rock, stone, or any material made from rock or stone. Mooring mast, mast where an airship can be tied up. Moulds, pieces of material with a space inside that concrete can be poured into to shape the set concrete. Reinforced concrete, material that is a mixture of concrete and steel rods. Spire, narrow cone or pyramid at the top of a building. Steel, strong, hard grey metal that is mostly made of iron. Stories, single floors of a skyscraper.